Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's AQA higher tier papers, polynomial factor questions. Students ran out of time or tested the wrong value and missed 2 or 3 marks. Sound familiar? If you've ever stared at a cubic and thought, where do I even start? This episode is for you.
That's me. I once tried long division in an exam and spent 4 minutes on one step. Brutal.
Today's focus, the factor theorem and the remainder theorem. One idea, lots of marks. By the end, you'll know why f of a equals 0 tells you x minus a is a factor, how to test candidate roots in 10 seconds, and when to do quick substitution rather than full long division. The concept. Start simple. A polynomial like f of x equals x to the 3 minus 4x squared minus 7x plus 10 looks scary at first, but the constant term, 10, gives you a short list of possible integer roots, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Why those? Because if x equals a is a root, then a must divide the constant term. Test them by plugging in. That's the remainder theorem in action. F of a equals the remainder when you divide by x minus a. If f of a equals 0, the remainder is 0, so x minus a is a factor. Simple as that.
So, instead of doing long division straight away, we try small substitutions first.
Exactly. Substitution is quick, reliable, and exam-friendly. Let's work through our example. Take f of x equals x cubed minus 4x squared minus 7x plus 10. Try x equals 1. F of 1 equals 1 minus 4 minus 7 plus 10 equals 0. That's a winner. We now know x minus 1 is a factor. You didn't do long division at all yet. You just found a factor.
Once you have a linear factor, you can divide to reduce the polynomial. You can use synthetic division, standard long division, or recognize patterns. Dividing our cubic by x minus 1 gives a quadratic. X squared minus 3x minus 10. That factors as x minus 5, x plus 2. So the full factorisation is x minus 1, x minus 5, x plus 2. Roots 1, 5 and minus 2. Job done.
Quick question. When would I need long division instead of substitution?
Good point. Use substitution first for integer candidate roots, especially factors of the constant. Long division is needed when the divisor isn't simple, for example if you're dividing by 2x plus 3, or when roots aren't integers and you need the exact quadratic quotient to proceed. I'll put worked long division examples on the website if you want more practice. The remainder theorem is the same idea in general. F of a gives the remainder when dividing by x minus a. That's useful if a question asks for a remainder rather than factors. Write f of a equals clearly to show the examiner you know the theorem. That often wins a method mark. The exam technique. Here's how marks usually break down on these questions. A typical 4-mark question could be split like this. M1 for identifying and testing a candidate root, M1 for showing the division or factor reduction, M1 for solving the resulting quadratic, and A1 for the correct final roots. Even if you can't complete all steps, writing f of a equals and showing your substitution often secures that first M1. Write each step so an examiner can follow your thinking. Don't just write the final factors. For example, show test x equals 1, f of 1 equals f of 1 equals 0, so x minus 1 is a factor. That's clear, gets the method mark. Then show the division or state the quotient and factorize. If you make an arithmetic slip later, those earlier method marks still stand.
What are the most common marking pitfalls I should avoid?
3 big traps. 1, testing the wrong value or a sign error, for example, plugging in +1 when the candidate is -1. 2, failing to factorize the quadratic fully and stopping too early.
3. Not writing f of a or the division steps so you miss method marks. Write down your test, write down the quotient and the factorisation. Write it down, don't just think it.
The quick win, a 10-second substitution check. After you find a candidate root and the factors, put the root back into the original polynomial and confirm you get 0. This catches 90% of sign mistakes and small copying errors. Memory cue. Test plus or minus the factors of the constant term. For constant 10, try plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Start with small numbers. They usually work.
So a 10-second routine. Pick a factor, substitute. If 0, you've got a factor. Then divide and repeat. That's very doable in an exam. Exactly. And don't forget the check at the end. Substitute each root back into the original polynomial. Don't skip the check. That line will save you marks under pressure.
Guided practice. Let's walk through a past paper style question together, step by step, as if you're timed. Question. Factorise fully and solve f of x equals 0 for f of x equals x cubed minus 4x squared minus 7x plus 10. First, list integer candidates, plus 1, plus 2, plus 5, plus 10. Try x equals 1. F of 1 equals 1 minus 4 minus 7 plus 10 equals 0, so x minus 1 is a factor. Write that sentence verbatim on your paper. Test x equals 1, f of 1 equals 0, so x minus 1 is a factor. That's M1.
Next step, reduce the cubic. Use synthetic division or long division. Synthetic is quicker. Dividing by x minus 1 gives quotient x squared minus 3x minus 10. Show the division or write the quotient clearly. That's your second method mark. Then factor the quadratic. X squared minus 3x minus 10 equals x minus 5, x plus 2. So the full factorisation is x minus 1, x minus 5, x plus 2. Solve f of x equals 0 gives x equals 1, 5, minus 2. Box your answers. That's the accuracy mark.
If I got the factor x minus 1 but then messed up the division, would I still get marks?
Yes. If you clearly show x plus 1 is a factor and present an attempt to divide, you will usually keep the M1 for identifying the root and likely the M1 for the division method, even if arithmetic slips mean the final roots are slightly off. Again, the examiner wants to see your method. Marks are there for the taking.
Quick reminders before we close. Always try small integer factors first. Write f of a equals, show the division or quotient, factor the remaining quadratic fully, and substitute your roots back into the original polynomial as a final check. That's a compact procedure you can reuse across papers. Test, divide, factor, check.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.